Okay, now we'll go through the redox memory shortcuts and analogies that has helped many of my students master this chapter. So we'll start off with the 4 definitions of oxidation and reduction. Okay, so the memory shortcut is SHU. For oxidation, it will be plus, minus, plus, minus. Okay, S is for oxidation state. H is hydrogen, O is oxygen, and E is electrons. So that is what SHU stands for. So a plus means there's an increase, there's a gain, and minus means there is a loss, there is a decrease. Okay, so a plus above S means there is a increase in oxidation state. So for example, it can be, the increase can be from +2 in Fe2 plus to +3 in Fe3 plus. So you jump from +2 to +3, therefore it's an increase, therefore it's oxidation. Okay. All right. Then the second definition is loss of hydrogen. So for example, if you look at this equation here, 2HBr plus Cl2 will give you 2HCl plus Br2. So if you look at HBr, it actually loses hydrogen to become Br2, bromine. There is a loss of hydrogen, therefore HBr is oxidized. Okay, so that's the second definition. The definition will be plus above oxygen, so gain of oxygen. So if we look at the example, S plus O2 to give you SO2. On the left side, we have S, and on the right side, we have SO2. So that is a gain of oxygen atoms. So since S gains oxygen, S is oxidized. Okay. And finally, the last definition will be loss of electrons. So for example, let's look at this equation here. Fe loses 2 electrons to give you Fe2 plus. Okay, so Fe is your iron metal, right? And it loses 2 electrons to become your iron 2 ions. Okay, your metals lose electrons to form positive ions. So this is an example of iron being oxidized. Okay, so those are your 4 definitions of oxygen and 4 definitions of oxidation. And all these definitions can be interchangeable. That means you can have increase in oxidation state and loss of electrons at the same time. Okay. Then we look at reduction. It will just be the opposite. So again, the memory shortcut is SHU, but now it's minus, plus, minus, plus. So think of it like reduction, reduce, right? You start with a minus. You start with reduce, minus. So minus, plus, minus, plus. Okay, so the first definition is minus S. So it's decrease in oxidation state. Okay, let's look at the example. You have Cu2 plus 2 electrons to give you Cu. Okay, so the oxidation state of copper decreases from what? +2 in Cu2 plus to 0 in Cu. So there's a decrease from +2 to 0. Therefore, we can say that Cu2 plus is reduced. Okay, that's the first definition. Next is gain of hydrogen. Okay, plus above H. So gain of hydrogen. If we look at the same equation as before, right? Cl2 on the left side and HCl on the right side. What's the difference? Hydrogen is being added, right? It gains hydrogen. So since chlorine gains hydrogen, chlorine is reduced. Okay, that's the second definition. So whatever substance gains hydrogen, it will be reduced. Third definition is a minus above O, so it's loss of oxygen. Okay, loss of oxygen, for example, you have CuO on the left side, and on the right side of the equation, you have Cu. So what's the difference? It loses an oxygen atom. So since CuO, copper 2 oxide, it loses oxygen, therefore CuO is reduced. Okay. Finally, the last definition, gain of electrons. Okay. So for example, your copper 2 ions, they gain electrons to become copper. Right, so it's like the opposite, right? Metals, they lose electrons to form positive ions. And from positive ions back to the metal, it gains electrons. So your copper 2 plus gains electrons, therefore copper 2 plus is reduced. Okay, so I hope you guys understand the 4 definitions better now using these 2 memory shortcuts. Okay, oxidation will be SHU plus minus plus minus. Then reduction will be SHU minus plus minus plus. All right, let's go on to the next one. Okay, this is the most important one, guidelines to assign oxidation state. So this will help you with identifying the oxidation states of any element in any compound or substance. Normally your syllabus, right, will throw you like 7 rules for this. Okay, but we can understand everything with just 5 rules. First, let's understand what does oxidation state mean. It is the apparent charge of an atom, ion, or molecule. Okay, let's start with the first rule. For elements and compounds with no net charge, that means it is neutral, there's no extra charges, there's no positive charge or negative charge, it is just neutral charge. For elements and compounds, the total oxidation state is 0. So let me explain. Example, you have an element, right, sodium. If the element is just by itself, just sodium, the oxidation state of sodium will be 0. Any element in the periodic table, if it's just by itself, the oxidation state of the element is 0. Then let's look at neutral compounds, okay? Sodium chloride. So you might be thinking, sodium chloride is an ionic compound. So there will be charges. Yes, there will be charges individually, but everything combined together, the charges will cancel each other out. So like sodium, it has a charge of +1. Chlorine has a charge of -1. So +1, -1, it will cancel each other out. Therefore, the whole compound will be neutral. Okay. So since it doesn't have a net charge, the oxidation state of sodium plus the oxidation state of chlorine will give you 0. Okay, the total oxidation state of all the elements equals to 0 for your compounds with no net charge. Okay, then for the second rule, for ions, right, the charge of the ion will be its oxidation state. Okay, because I already said oxidation state is the apparent charge. Okay, so for ions, the charge is the oxidation state. So if we think of chloride ions, right, what is the charge of chloride? It is -1. So what's the oxidation state? -1. Okay, pretty simple. But what about polyatomic ions? So that these are ions that contain multiple elements, right? So for example, SO42-, it contains sulfur and oxygen. Okay, SO42-. But you see, right, there's a 2- here. That is the charge of the whole ion. So the total oxidation states of all the elements inside is equals to that charge, which is -2. So S plus 4O equals to -2. Why is there a 4 for oxygen? It's because there's a 4 here. Okay, there's a 4 over here, which means there is 4 oxygen atoms. So we need to take that into consideration as well. Okay, there are 4 oxygen atoms in SO42-. Right. And then if we look at an ionic compound again, let's say MgO, the total oxidation state of magnesium and oxygen will be 0. Okay, oxidation state of magnesium plus oxygen is 0 because it is a compound with no net charge. Okay, the charges cancel each other out. So oxidation state is 0. But what about individually? Individually, they are ions, right? They have charges. So what is the charge of magnesium? It is +2. Based on the periodic table, you can find that it's +2. So the oxidation state will also be +2. Okay, because the ion has a charge of +2. Then oxygen, it has a charge of -2. So the oxidation state is -2. Okay, so it's pretty straightforward, right? You just need to know the ion, see the charge, and the charge will be the oxidation state. All right, let's move on to the third rule. Oxidation state of hydrogen is +1 in most compounds. Only in metal hydrides, like sodium hydride, the oxidation state of hydrogen is -1. So let's look at most compounds, right? HCl, NH3, H2SO4, these are very common compounds that contain hydrogen. For all of them, the oxidation state of hydrogen will be +1. Okay, it is +1 in most compounds. The only time it's not +1 is in metal hydrides. So what are metal hydrides? Your sodium hydride, magnesium hydride. Basically, when hydrogen acts as a non-metal, and then it forms an ionic compound with another metal, that is a metal hydride. Okay, so the oxidation state of hydrogen in this case is -1. But In other cases, it will always be +1 as long as it's inside a compound. But what about hydrogen individually? Remember, for elements individually, it will be 0. Okay, so only in compounds it will be +1 or -1. Okay, let's move on to the fourth rule, oxidation state of oxygen. Okay, so oxidation state of oxygen is -2 in all compounds, except for hydrogen peroxide H2O2. In any other compounds like H2O, NO3 minus, CaCO3, the oxidation state of oxygen will be -2. Okay. Then in H2O2, hydrogen peroxide, the oxidation state of oxygen is -1. Okay, it's -1. That's the only exception. In other cases, as long as oxygen is in a compound, the oxidation state will be -2. All right, that's the fourth rule. And the last final rule, oxidation state of group 17 elements, also known as halogens in compounds, is -1. Okay, that means if you see a group 17 element is in a compound, the oxidation state of the element is -1. So example, in HF, F fluorine is a group 17 element, so the oxidation state of F is -1. In MgCl2, chlorine is group 17, and it is inside a compound, right? Magnesium chloride. So the oxidation state of chlorine is -1. Okay, these are the 5 rules for the guidelines to assign oxidation state. All right, let's move on to the final one, which is oxidizing agent. So think of this property agent analogy, right? What do property agents do? They help people sell their property, right? And then after successfully selling the property, they themselves get a commission, okay, from selling the property. So similar to property agents, oxidizing agents, they cause other substance to undergo oxidation, to oxidize. Okay, while itself, it will reduce. Then for reducing agents, it causes other substance to reduce, to undergo reduction. Okay, then the reducing agents itself, it will oxidize. So it's very similar to property agents. Let me give you an example. Acidified potassium manganate 7, okay, KMNO4, is an oxidizing agent. Aqueous potassium iodide, Ki, is a reducing agent. So what happens when these two react together? Firstly, acidified potassium manganate 7 solution, KMNO4, it changes from purple to colorless when it is reduced. Okay, and then your Ki solution, aqueous potassium iodide, changes from colorless to brown when it is oxidized. Okay, remember your oxidizing agent reduces and your reducing agent oxidizes. So when solutions KMNO4 and Ki react, when the oxidizing agent and reducing agent react, there will be a redox reaction. Okay, so both oxidation and reduction will occur. Okay, redox reaction. Since KMNO4 is an oxidizing agent, it will oxidize Ki. Okay, so Ki will change from colorless to brown. Okay, because it is being oxidized. And since Ki is a reducing agent, it will reduce KMNO4. So KMNO4 will undergo reduction and change from purple to colorless. So that is how oxidizing agents and reducing agents work. They need each other in order to reduce or oxidize. Okay, so that is it for all the memory shortcuts. If you would like a copy of this PDF, join our Telegram channel. The link will be in the description and you can download it for free. All right, see you in the next video.